So this is the first part of the project where I have created a simulation in which there will be a subsystem, different subsystem for battery and different subsystem for controller. So for each system I have assigned 8 sensor, and 8 sensor will give different type of value of temperature. For that we can adjust the base temperature for battery as well as for controller, and also we can adjust the variance that we need to generate the data. So this system will generate the data on which our ML model can be trained. Also, this system is needed to see that if system is working perfectly or not. Uh, because of that, we can conclude that if system is perfect, then we will move toward the hardware in loop where all calculation will happen in the hardware. Currently, this is the part of system where the sensor data will be generated, or the simulation will act as a 16 different temperature sensor. And this is the part of subsystem where it is acting as a hardware, means in this part the average of the temperature from system 1 and system 2, that is controller and battery, is calculated. So let's start the simulation. The stop time is 20 because we just need to identify that if the system is working or not, and the data can be generated on the Excel sheet or not. So let's start. Simulation is successfully complete. Now we have to check that if the data is generated is correct or not. For that we have to open the out variable, that is nothing but two workspace. In that you can see that there are two workspace variables, that is out dot simount and out dot simount 2. So we have to look for out dot simount 2, which will contain 16 into 3 vector data. As you can see here, for the battery sensor we have assigned the address from 101 to 108, and for controller sensors we have assigned the address value from 201 to 208, and these are the different temperature reading, and these are the average that we get. Now let's see the simulation in detail. Here you can see this is the main block which can generate a random temperature signal, but it is not completely random. We can adjust the variance, or you can say the randomness of the sensors from variance of battery value and from variance of controller value. Also we will select the room temperature from which the reading will start counting. Okay, and these are the base temperature controller, or you can say it is the baseline where the temperature will remain constant, but of course there will be some variance. So now the data is generated, that means the system is working. Now we have to move to the next part, that is hardware in loop. For that I have designed a different type of simulation model. We need to check that first. So here you can see this is the proper simulation that I have created for hardware in loop, where this part is for dashboard. From here we can control this subsystem, and in this subsystem we can generate the sensor data. As you can see, here are much more blocks than the original software in loop simulation. This is because what will happen here, that this is the main block which will generate the different temperature. Then this is the organizer which will organize the temperature, and it will give specific address to that temperature, so we can understand that which temperature sensor have what type of reading. After that, this will also do one more thing, that this will count a real clock. Here you can see we have attached the clock. This clock is connected to our real time, so that will also organize in this function block. After that, that data will get converted into 16 into 2 vector, and it will further transfer to the COM8, where our Raspberry Pi Pico, that is RP2040 microcontroller, is connected, and all the average calculation will happen on that microcontroller, and we can see the output of that microcontroller to COM3, because RP2040 has two serial ports for communication to the PC, one for sending and one for receiving. Okay, so from here you can see we can adjust the room temperature from where the counting will start. This is a switch. If a user want to control temperature manually to take the reading on the microcontroller, so this has to be off. But for me, I have to generate the data to train the ML model based on the real-time OS in the microcontroller. That's why uh, I do not off this switch, and these are the parameters that we have to decide for constant temperature of controller and constant temperature of battery. Constant temperature means at what temperature all the reading should be there. So ML model can easily identify if temperature is rise or decrease below the baseline, then there will be some fault in the future. This can be helpful for early fault detection and for root cause analysis. And of course, there will be some variance controller that we will use. So first of all, I will tell you that how can we connect our RP2040 to our MATLAB, because I don't have a proper Raspberry Pi Pico board with me. I have a Vicharak Shrike Lite board, which is consists of microcontroller plus FPGA board. So there are some different instruction for that. So let's start with the MATLAB part. Okay, so in this model you can see that for a base temperature of controller I have set it to 35 degrees Celsius, and for base temperature of battery I have set it to 42 degrees Celsius, and the room temperature means from where the calculation will start is set up to 30 degrees Celsius, and the variance for controller is up to 1.2, or you can say 1.1 degree variance, and variance for battery is set up to same 1.1 or 1.2. Okay, so first of all we will see that what type of microcontroller we are using for hardware in loop. So I will go to the droid cam, and here you can see this is the microcontroller that I am using. This is RP2040. Now currently it is connected to MATLAB, because RP2040 has a two inbuilt port that we can use for sending and receiving. I will show you in device manager. As you can see in device manager, these are two ports, COM3 and COM8, that we are going to use. Now next thing is here you can see for the data transmission we are using COM8, and for data reception we are using COM3. So this is the drive for the microcontroller. Here we need to adjust this two file, that is boot.py and code.py. In code.py we have to upload the Python code which will tell the microcontroller what to do from the data he will take from the simulation. Next, okay, this is our simulation model. Now what we have to do, we have to just write a code in a MATLAB command window. So this is the code. Here we are going to take data from port 8 and we have to print it to the port 3. Okay, this is the proper code, and then we have to make that all data in a Excel sheet. So let's run this, and we are going to use step forward, so we can see the time on which it will transmit the data. Okay, so let's start. So it will take some time for compilation, and after compilation as you can see, command window is already working perfectly fine. So this is the data we are going to get from the first reading at time 0.00. At time 2.00 we are going to get next reading. As you can see here, this is the packed cell and this is the MOSFET layer. Packed cell means the battery, and MOSFET layer means the controller. So from this we can identify that this is the controller part and this is the battery part, in which for sensor ID 101 the temperature is 30.80, for sensor ID 102 the temperature is 31.12, and like that there is a variance in the temperature. Similarly, the temperature is same for the microcontroller, but as you can see here, the temperature for battery is start from room temperature, whereas the temperature for MOSFET is not start from the room temperature. This is because when we calculate it to the e to the power minus z, the controller have tendency from which the temperature is suddenly increased when controller start to work. Okay, so after that we just need to increase the time, and as you can see, if I just increase time, it's gonna take so much time. So I will stop it and I will show you what finally the result will be. Okay, so I will stop it, and will be our result, that is the combined combination of proper temperature, the IP address, and the location. Obviously the mean also. Here you can see the mean is calculated by our own hardware. The mean is calculated by this hardware, which is our RP2040, and from this I have performed the hardware in loop concept, and this is the Excel sheet that I have created. As you can see, this is the Excel sheet. This is the timestamp. This is the location of subsystem from which we are going to derive a ML model. This is the temperature for different types of IDs of a sensor, and this is the mean. So from this Excel sheet, if I have run this for 30 minutes, I have much more data on which I can train the model, like a Gaussian model or a tree model, on which I can make a system, or you can say the thermal system, which will predict if temperature is going above some certain degree in sensor ID 010 and 015. That means there is a problem in temperature sensor, which will lead to cause a battery malfunction or a controller malfunction problem in future. So I am going to make that thermal subsystem also, or you can say thermal control system also in future. But for now, I have demonstrated hardware in loop concept with the practical performance in the RP2040. And this is not the only part. I will also show you that this is the code of the hardware. So I'm not using a simple Python code here. Okay, notepad. I'm not using a simple Python code here. I'm using a real-time OS. I have used the proper kernels here. I will show you. This is the proper code, as you can see, and I'm using the kernels here. As you can read the code. Okay, so some kernels are used here, means a proper real-time operating system is running, or you can say operating in the microcontroller. So that's my initial level of project. I have to make it proper, to make it properly a thermal control system.